If I have two parallel wires and I have current both going the same direction, what I find is that there's a magnetic force between them. Watch. Would you say that's a force? Yeah. Okay. Calm down. Now those wires are getting hot because I've got no resistance in here and it's hooked to a car battery. If you leave those connected long enough, they'll just start smoking and melt right down onto the table. Okay, we won't do that. Let's see why they attract each other. This is a great example of the type of homework problem you have, not only for class, but also for tutorial. It's also a great example of a magnetic force problem in general. And that's, you've got to learn what you care about and what you don't care about. Okay? If I'm looking for the magnetic force on one, I have to be careful about what I care about. Both wire 1 and wire 2 generate magnetic fields. But I don't care about both of those fields. One is not pushing and pulling on itself. 2 is pushing on 1. So I care about the magnetic field due to wire 2. By right-hand rule number 2, that magnetic field is going into the board over here, coming out of the board over there, and wrapping around. I know what the magnetic field due to wire 2 is everywhere in the room. But I don't care. I don't care about it everywhere in the room. I care about it right here where it's pushing on wire 1. Now, right there, the field due to wire 2 is coming out of the board by right-hand rule number 2. Okay, now I can ignore wire 2. It's done its job. It set up the field. Now I ask, how does that field push that current? Which right-hand rule gives me a push, a magnetic push? 1. So I reach in the direction of the motion, the flow, the current, and I turn my wrist so I can wave in the direction of the B field. My thumb is in the direction of the force. Now, if I want the force by 1 on 2, I could just use Newton's third law. If 2 is pulling 1 this way, then 1 must be pulling 2 the opposite way. Or I could start at the beginning, and I can ask, which field do I care about? Well, if I'm looking for the push on wire 2, I care about the field generated by wire 1. It doesn't push on itself. Wire 1 is creating the field that pushes on 2. Again, I know that this field wraps around like this. I know what it looks like everywhere in the room. But I don't care everywhere. I just care over here where it's doing the pushing. Okay? Now over there, by right-hand rule 2, it's going into the board. Into the board. Okay? So now, I'm ready to use right-hand rule number 1. I reach in the direction of the flow, the current. I turn my wrist so that I can wave in the direction of the B field, and I get the force that way. Now, if those wires are sending current in opposite directions, and I can make that so by pulling the switch the other way, what's going to happen? They'll repel. Whoa, is that cool or what? Again, making them hot. They're very hot to the touch. Okay.